Here we have a set chapter. I selected set chapter to explore it. Uh, yes, this is a class 11th and first lecture. This is first chapter, which name is set. We will explore it in details. And now we are starting. Now we are starting. Here, before learning sets, we are going to explore set chapter. But here it is saying that before we learn sets for class 11, let us know first what is a set. This is compulsory to know what is the meaning of a set. A set is a well-defined collection of objects. We will have a lot of objects, and a lot of objects will be defined well. We will have a collection of objects. We will have a lot of objects, and this would be a group, you can say, whose elements are fixed and cannot vary. Cannot vary. We will see what is the meaning of this. Cannot vary. It means a set. It means a set does not change from a person to a person. For example, this three. We cannot replace this three by another. This is what is meaning. Like for example, the set of natural numbers up to 7 will remain the same as 1, 2, 3, 4, 5, 6, 7. We cannot replace this by person. Okay, by person. This is what is the meaning of cannot vary. Still, if we say the set of best players in a football team, then the name of footballers could vary every time we ask about the best player, who are best player, whoever are best player. Just send that player to play the football. Like that we say. Here, look. So each person has its own choice to consider the best player. Similarly, if we speak about the set of rivers in India, the elements of this set will remain as the same. So this is a real life example of a set. In mathematics, we represent these sets in curly brackets. Whatever will be important, I will be telling you. I will be telling you what here we saw a example of a football. You can ignore it this example, otherwise you can understand this example. Otherwise, I am telling you here set how to represent set. So represent set is represented by this symbol, this curly bracket. This bracket is known as curly bracket. We represent a set in mathematics by this bracket, curly bracket. So wherever you are, whenever you pronounce it curly bracket. Now we have this much topics of this chapter. First is a set, subset, union of sets, complement of sets, finite and infinite sets, sets, subset and superset, types of a set, universal set, disjoint set, then important questions, class 11 maths chapter. Here we will have a lot of questions based on this chapter. Apart except this, we have this much topics that we will be exploring in too much details. Don't worry. But remember, we will not accept unnecessary things. Our focus will be on the main points. From this, what did you understand? From this, you understood meaning of a set. You understood meaning of a set. You understood how to represent a set. So a representing of a set is like that. By using this uh, set is represented. So remember, we cannot change, we cannot replace this by other object. And a set is just a collection of objects. In a set, we will have a lot of objects. Like in this, we applied this set. This is a set curly bracket. We are able to say that yes, this is a set. In this, we have 7 objects. We can call one as object. So we have 7 objects in this. So this is a group of natural. Can we say that yes, in this set we have a group of natural numbers? Easily we can say. That is how we define a set of something. Now, okay, introduction to set. Union set definition we are the now let's start from the beginning. Here, set in mathematics are organized collection of objects and can be represented in set builder from form or roster form, builder form or roster form. Usually sets are represented in curly brackets. Yes, we use these brackets to represent a set. For example, A is equal to, in this set we named A set. The name of this set is what? A is equal to, in this set we have this much objects 1 2 3 4, and it is surrounded by this curly bracket. This is a complete set. Also check this set symbols. Let's see what is the set symbol. We will see it later. And in set theory you will learn about the sets and its properties. It was developed to describe the collection of objects. You have already learned about the classification of sets. Here the set theory defines the different types of sets, symbols and operations performed. Table of contents. Here one by one we will discuss each these types of sets. We have understood what is a set. Now we have this types of sets. We have types of sets. Let us discuss the types of sets. First is empty sets. From empty you are crystal clear that yes, set is empty. Set is what? Empty. The set with no elements. There would be no elements in a set, or null elements is called an empty set. This is also called a null set or void set. It is denoted by this. In this we don't have any elements, that's why this is empty. Just you will use a open curly brackets and a close curly brackets. For example, let us set x is equal to x is to x is the number of the student studying in classes 6th and 7th. Since we know a student cannot learn simultaneously on two classes, therefore set X is an empty set. X is an empty set. Singleton set. Just we are taking a brief definition of types of sets. We are not going into too much details about it. Just you can take it as a little knowledge. It as a little knowledge. Next set we have a singleton set. The set which has only one element is called a singleton set. For example, set X. Here we named this set, and name of this set is what? X. Set X. In this set we have one element which is a 2. If there is a nothing element, then we will call this set as a empty set. Now in this set we have one, so this set will be singleton set. Finity and infinity sets. Finity sets are the one. Finity which means limited. Infinite. Finite which means limited. Infinite which means unlimited. Finite sets are the one which has a finite numbers of elements, and infinite sets are those whose number of elements cannot be estimated. It will be it will be more, even we cannot imagine. But it has some figure on number which is very large to express in a set. In a set, for example, set x is equal to, in set x we have this 1 2 3 4 5. Okay, is a finite. This is a limit. In this we have 5 elements. So this type of fixed limited elements will be known as finite finite set, as it has a finite number of elements in it. Set y, number of animals in India. Here we are saying we are not numbers in this. We are a statement, and by this statement you are able, this statement is giving you a number of animals which is not possible to imagine. So set y, in this we have number of animals in India. It can be a lot of, is an infinity set, because we are not able to imagine. If we imagine, then it can be anything. Yeah, isn't it? So in this set, from this set we are understanding that yes, it is saying it is talking about infinity, and it is talking about finity, as there is an approximate number of animals in India, but the actual value cannot be expressed. Yes, this is truth. But we can represent a statement. We can say yes, this much would be. We can estimate, that's it. But actual number we cannot express. We cannot express in set. So this type of a set, we will consider it as an infinity set. Next we have equal sets. When it comes to equal, then we will have to take at least two sets so that we can compare. Here we have two sets, x and y are said to be equal if every element of a set x is also the elements of a set y. Elements in one set is equal. With examples I would like to tell you. If every element of a set y is also elements of a set x, it means set x and set y have the same elements, and we can denote it as this: x is equal to y. X is a set, y is also set. We have both sets, and we are saying x set is equal to y set. Here we are saying number of these elements are 4, and in this also 4. So in both sets, numbers of elements are same. That's why we are saying both are equal. And if x is equal to set of even numbers, here we are saying in this set we have even numbers, and in other set we have a set of natural numbers. So can we say, so of course it will not be equal. This is the even numbers, and this is the natural number. Even number is what? 2 4 6 8, and here we take 1 2 3 4. So both are different. So now we will call it as a x is not equal to unequal. You can call it unequal. X set is not equal to y set, because natural numbers consist of all the positive integers starting from 1 2 3 4. It keeps go till the infinity. But even numbers start with the 2 4 6 8 and so on. Both are very different. That's why we cannot say that both the sets are same. Now we have subsets. We have subset. Next we have subset. A set x is said to be a subset of set y if the elements of set x belongs to set y, or you can say each element of set x is present in set y. What are we saying? We are saying in one set we have some elements. Now if this some elements are present in another set, then we will call this as a y set will be subs. We can, so this type of a set will be called as subset. Subset is a set. Subset is a subset are sets in which one set one set has elements who will be in other set. Then this is type of a sets will be called as subset. Each element of a set X is a present. Yes, it is denoted with the symbol this X. All elements we are denoting like that. So here we are saying all elements of this set is in this set. That is what we are saying by representing. If all elements of this set is in this, then we will use this type of symbol like that. We can also write the subset notation as X, then this Y. If A belongs to X, A belongs to X. Thus, from the above equation, X is a subset. X is a subset of Y. Y is a complete set, but X is a subset of Y. If A is an element of X, implies that A is also an element of Y. Each set is a subset of its own set, and a null set or empty set is a subset of all sets. Yes. What null or empty? Here in this word null empty would be subset. Null set subset would be would be its own subset. Now power set. This was about subsets. Now we have a power sets. When it comes to sets, plural sets, it means we will take two or more sets. The power set is nothing but the set of all subsets. Whatever we have a number of subsets. Let's explain how. We know the empty set is a subset of all sets. Yes, and every set is a subset. Every set is a subset of itself. Taking an example of a set X, in this is also in this empty set is a subset of this set X. From the above given statements, we can write this is a subset. This empty is a subset of this X, and here 2 is a subset of this set. 3 is a subset of this, and 2, 3 is also a subset of this. So we have how much? 4 subset. This 4 subset are this 4 are a subset of this set. This is also set. This is also set. This is also set. This is a singleton set. Singleton set is a set which has only one element. This is also set. So these are power sets. Power set is a set which has a set we take a 2 set, and a empty set would be subset of another set. Then each elements. Okay, if you have understood through this, then I am moving ahead. We are crystal clear about power sets. Universal sets. A universal set is a set which contains all the elements, okay, of the other sets. Generally, it is represented as a union. This is a union. Now, for example, set X. This is set X, and this is set Y. What is happening here? Set X and set Y. Then we have one more set X, set Z. Here in this set we have 2 1 2 3. In this 3 4 3 4 5 6, and in this 5 6 7 8. So what will be universal set of this sets? So then we can write universal set as a u 1 2 3 4 5 6 7 8 9. What is the meaning of this universal set? Here meaning of this would be what we don't take common elements. We don't take common elements. Here 3, in this 3, this 3 are coming 2 times. So rather than taking 2 times in universal set, we will take 1 times. Here this 5 6 and in this 5 6 both are coming 2 times, so 1 time we will take. So universal set of this sets would be what? This, nothing common. In intersection we will see only common. From the definition of the universal set, we can say all the sets are subsets of the universal set. Yes, yes. This is a subset of this, and this y is also subset of this, z is also subset of this, because all these elements of this set is in this subset. In this set, all these elements of this set is in this set. All these elements of this set is in this. So we can say this is a subset of this. This is a subset of this set. This is also subset of this set. Subset is just a piece of another set. Next we have all the sets are subsets of the universal set. X, then this u y, okay, subset. This is what subset. X set is a subset of universal, y is a subset of this. So here this is all the meaning of this is what? All elements of y is in this universal set. Here meaning of this is what? All elements of z is in this union of sets. Just we understood. Let's see again. A union of two sets has all their elements. It is denoted by u. For example, set X, we have this set, this set, two sets, we have two sets. The union of set X and set Y will be like that, X union Y. Here we will take 2, 3, 7, then 4, 5, 8. We added this and this, both we added, and common things we will ignore. We will ignore common things. So this here we are saying X, sum of X and Y would be this, and common thing we will ignore. Properties of a union of sets. Properties of a union of sets. Here X union Y. So it can also be written as Y union X. Same here, X union Y union Z. Same here, X union. This is what commutative law. This is what commutative law. In this, we can also write X union empty set is equal to X colon empty set is the identity of union. This is also empty. X union X is equal to X. U union universal set union X would be universal because it is already in this. That's intersection of sets. Yes, in this we will take a common thing, common elements. We will take common elements. Intersection of a set. Set of all elements. Set of all elements which are common to all the given sets gives an intersection of sets. It is denoted by we will have two or more sets, and whatever will be common of our given sets, we will take a common, and we will create another new set, and in a new set we will put common sets, common elements. For example, we have these two sets, set X, set Y. In this we have 2, 3, 7, this much elements and this much elements. Now what is a common in this? We have two common. This is 3, not 3, 7, not 3. So 2 is a common. We will create another set by use by like that we will create. So x intersection is like that, and this is a union. And intersection which means common elements. Intersection which means common element. Difference of sets. The difference of sets. The difference of a set. The difference of a set x and set y is such that it has only those elements which are in the set x and not in the set y. X minus 1. What is the meaning of this? In the same manner, y minus x. For example, if a set x is what? Set has this much elements a, b, c, d, and y is a b, c, e, f. Then subtraction would be what? X minus y. So here we are saying b minus b. It will go b minus b. It will go a. Then we have a c minus c. This will go. So in this we have x minus y. In this we have ad. X minus y we will have ad. Y minus x. We are subtracting this from this from this. So of course we will so this b will go and then this c will go. So we will have ad, but y minus x. This from this from this, then b and then c. So ef, we got ef in this. So you will have to do like that when it comes to difference. Disjoint sets. Disjoint sets. If two sets x and y have no common elements, okay, this is a union set, and their intersection results in 0, then set x and y are called disjoint sets. For example, it can be represented as x intersection y is equal to 0 because they have this set does not have any common element. If this set does not have we have two elements and both two sets we have two sets and both sets does not have any common elements, then we will represent the intersection like that, x 0. We are saying that there is nothing common elements in this set and in this set. So this is done. We are done with disjoint sets. We are crystal clear about it. Also this intersection of sets, union of the sets, universal sets, the next power set, the next subset, the next equal set, the next infinite and infinite sets, then singleton set, then empty set. These were types of sets. Now next, let's start. Let's see this set. In mathematics, okay, we know meaning of a set. Now let's see definition of a set. Hold on. Here it was a table content. We saw this union of a set, not complement of set. We saw this infinite and infinite set, subset, superset. We saw this types of a set. We saw universal set. We saw disjoint set. We saw all this we saw. So this is a table content, and we can explore all each this in details. For example, this set. this is set. Now we have with a definition. The definition of a set is here. Set are represented as a collection of well-defined objects or elements, and it does not change from person to person. A set is represented by a capital letter. The number of elements in the finite set is known as a cardinal number of a set. What are elements of a set? Let us take an example. This is what this is set. In this set, 1, 2, 3, 4, 5. These are elements. Since a set is usually represented by capital letter. Yes, this set name of this set will be represented as a capital letter, not a small letter. Thus, this set is the name of a set, and 1, 2, 3, 4, 5 are the elements. 1, 2, 3, 4, 5 are the elements of this set or members. These are members of this set. The elements that are written in this set can be in any order but cannot be repeated. Yes, this should not be repeated in this. 3 should not come 3 times, 4 times, 5 times. Okay. Now all these set elements are represented in small letters in case of alphabets. Okay. Also we can write it as a 1 belongs to A, 1 belongs to A, 2 belongs to A. We are saying A is in this set, 2 is in this set. Let us see. The cardinal number of this set is 5. Some commonly used sets are as follows. Now here you will see these signs in set, so it will be important to see to understand these symbols. N is just natural. We are saying a set of all natural numbers. When we will see this, so remember this is just a natural number. Here in a set, if this is written, then you will have to understand that yes, it is saying natural. This is a set of all natural numbers. Z is represented to show integer numbers. Integer number is represented by the Z letter, set of all integers. Set of all integers. Q is what? Set of all rational number. Rational number is represented by Q. R is a real number. Z is a set of all positive integers. Here we have Z plus. If Z minus, then set of all negative integer. Only Z, set of all integer numbers. Q is a rational, R is a real, N is a natural. If all these are written in a set, then you will have to understand yes, in a set, a set is a all natural number. A set has all natural numbers. For example, here n is written, then you would say if this set has all natural numbers. If Z, then you will have to understand that yes, this set has all integer numbers. If Q, then you will understand that yes, this set has a rational number, all rational numbers. R, all real numbers. Z plus all positive numbers. Now clear. Till here we are clear. Order of sets. The order of a set defines the number of elements a set is having. It describes the size of a set. The order of a set is also known as a cardinality. Let's explore it. The size of a set, whether it is a finite set or an infinity set, said to be set of finite order or infinity order respectively. Also check this. We will check this later. Don't worry. Representation of sets. Representation of sets. The sets are represented. Yes, we know. This set is represented by applying curly brackets. For example, we have this much elements 2, 3, 4. These are elements, and we apply what after one element we apply comma. It is a compulsory, and we surround it by using these curly brackets. Or in this set we can have any elements. We can have this ABC, and name of this would be elements. Or ball, bat, ball, wickets. All these are in text, this is in number, this is in alphabet, this is in words. The elements in these sets are depicted in either the statement from roster form or set builder form. Statement 4. Statement 4. Statement 4. In statement 4, the well-defined description of a member of a set are written and enclosed in the curly brackets. We know. Statement 4. For example, this set of even numbers less than 15, we will say n less than 15, n less than 15. In statement form, it can be written as even numbers less than 15, even number less than 15. This is how we can represent any statement for in a set. This is known as statement form. Statement even numbers less than 15, so it will start even numbers. We are talking about even numbers, so 2, 4, 6, 8, like that, 10. Okay. Roster form. What is a roster form? In a roster form, all the elements of a set are listed. For example, the set of natural numbers less than 5, so we will stop till the 4, 1, 2, 3, 4, 5. Natural numbers 1, 2, 3, 4, 5, 6, 7, 8. It will keep going on. Natural number less than 5, 1, 2, 3, 4, 5. Therefore, the set is n, and here 1, 2, 3, 4. This is a roster form. Here it is infinity and this is infinity. So this infinity would be roster form. Set builder form. The general form. What is the set builder form? Let's see. This set builder form will look like this. It will look complicated, but don't worry, just you will have to understand. The general form is this is the name of the set. Okay, now here we are saying x, then column property. What is the meaning of this? Example, write the following sets in this set builder form. Sets in set builder form. A in this set has a 2, 4, 6 set solution. 2 multiple 1, 2 multiple 2, 6 multiple 2 multiple 3. Okay. So this set builder form is what? So set builder form of this would be what? X, then column x is equal to 2n. We are saying 2 multiple 1, 2 multiple 1, and it will keep going on. And here we are saying n, this number belongs to natural. And 1, it will start from 1, would be natural, and it will stop till the 4. This is what it is telling you. Clear? So here you will have to understand this, then you will work carefully. Also, Venn diagrams are the simple and best. So this is known as this type of a set is known as a set builder form. Roast form, statement form. Statement form is just a statement, and roster is just this number. It will be clear. It will be very clear. But when it comes to set builder form, then here you will have to understand very carefully. Here you will give a logic. Here you can say this would be puzzle. Set builder form would be puzzle. You will have to understand carefully. Types of sets. We have several types of sets in math. They are empty set, parity set, infinity set, proper set, equal sets, etc. There are a lot of, and some these sets we have discussed. Don't worry. But one thing, proper set we didn't discuss. We will discuss. Don't worry. Let us go through this classification of sets here. Empty set, we know in a set would be nothing. Here you can see, and it can be represented as this null, which means empty. But we will not ignore symbol of set. A set of apples in the basket of grapes is an example of an empty set, because In a grapes basket there are no apples. There are, but the basket is a set. Basket is a set, and in a basket there are no apples. Singleton set in a set which has only one element. Infinity it will be fixed, and infinity it will not be fixed. It will not be fixed. Equivalent. What is equivalent? Which means if the number of elements is the same for two different sets, then they are called equivalent sets. The order of the set does not matter here. It is represented as number of elements in this is equal to number. We are saying we are we are talking about number of elements in a one set is equal to number of elements in another set. If both are equally, then we will call that set as a equivalent set. Where A and B are two different sets with the same number of elements. Number of elements. If a number of elements in both sets are same, then we will call it as a equivalent set. So here we are saying number of elements of this set is equal to number of elements of this set. Example, if A, in this we have 4 elements, okay, and B, in this set we have how much sets? 1, 2, 3, 4, 4 sets. Number of this set has a 4, number of this set has a 4, number of elements of this set has a 4. Both are equally, so we will call it as a equivalent set. Now next we have equal sets, which means elements will look similar as it, and number would be same. Number should be same. Number of elements should be same, and element should be same. Element here 1, 2, 3, 4, and here 1, 2, 3, 4. Both are same. It doesn't matter where is the index number of element. Okay, both are equal. A is equal to B. Disjoint sets, we know these two sets. We are crystal clear about it also. Okay. We have this A2 in this set. We have this. So then 1, 2 is in this set. This is what is a subset. This is a subset is represented by using this symbol. Similarly, other sets of a set A. The set is also a subset of itself. Okay, if A is not a subset of B, then it is denoted as like that, just cross. Yeah, we were curious about knowing a proper set. Let's say if A, all the elements A, yes, A is a subset of B and A is not a subset of B, A is not equal to B, then A is called the proper subset of B, and it can be written as like that, A subset of B. Example, if a set has a 2, 5, 7 is a subset of this, yes, we know, then it is not a proper subset of B. Yes, this is not a proper subset of B, but this is okay, is a subset of B 2, 5, and it is a proper subset because of all this elements, all elements of this set is in this, but in this subset has more apart from this elements, so this will be known as a proper subset. Now in this also, but this subset does not have more apart from these elements. Superset, it is also very important. We know about subset, but what about the superset? Let's say set is a set set A is a said to be the superset of a B if all the elements of a all the elements of a set B are the elements of a set A. It is represented as like that. This is a superset, just opposite of a subset. For example, if a set A, we have this set A, set B. Now this is just opposite. If all the elements of this set is in this, then direction of this set subset would be like that. So this would be superset. Then set A is a superset of a B. Otherwise you can say B is a subset of A. Universal set, we know operations on sets. It is also important. Union of a sets, intersection of a sets, a complement of a set, Cartesian product of a set difference. Now one by one let's explore. Let's see here. Basically we work more on union and intersection of a sets operation using Venn diagram, and we are familiar to union and intersection. Union does not have common elements, and intersection has only common elements. This is what we know about them. First of all, let's clear this. Union of a sets. If a set A and set B are two sets, there are two sets. Then A is a union of B. A union B is this set that contains all the elements of A and set B. It is denoted as A union B. Here it is saying that if we take A union B, here we are saying we are adding this with this. Here you can see we have two sets, and then A union B is will look like that, where we are adding this with this. So after adding, it will look like this. We created another set. This is a union of a sets. Now intersection of a sets. So here we will take only common things. So first of all we should have two or more sets. This is one, this is another. In this, what is the common elements? So there's a three, nothing is a common. Then A is a intersection B. Then A intersection B. Here nothing is a common. So we will represent this as like that, nothing or null. Since A and B don't have any element in common, so their intersection will give null set. Now next, complement of sets. Let's explore it. The complement of any set, say P, let's say we have a set P. Set P is the set of all elements in the universal set that are not in this set P. It is denoted by P. Okay. Properties of a complement sets. P union P dash is equal to union. I think universal. It would be universal. It is universal. P intersection P dash. This is a null. Law of double complements of a set. T is the set of all elements in the universal set. P is the set of all elements in the universal set that are not in set P. It is denoted by P. What is it saying? We will see later. Law of a double complement. Laws of empathy. Okay. Cartesian product of a sets. If a set A and set B are two sets, then the Cartesian product of set A and set B is a set of all ordered set pairs A, B, such that A is an element of A and B is an element of B. It is denoted by A multiple B. In details, let's explore it. We can represent it in set builder form such as A multiple B. Here we are saying A, comma B, column A belongs to A. Okay, A belongs to A and B belongs to B. This is what we are saying. Example, set A, we have this 1, 2, 3, and set B, we have a bat, ball. Okay, in this we have 3 elements, in this we have 2 elements, and then we are going to multiply this. these two sets, then what will happen? First of all, we will multiply this by this, then this by this, then this by this. Now next time we will multiply this by this one, next ball multiple 2, ball multiple 3, like that we do. Bat not multiple, but like that we write 1 comma bat, 1 comma ball, 2 comma bat, 2 comma ball, 3 comma bat, 3 comma ball, like that we put. One pair, we make a pair. This is known as Cartesian product of sets. Here remember, in details I would like to tell you here. First of all, we will take this, then this, then this, then this, then this, then this, then next time this, 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 the next time, like that it will keep going on. Now what is a minus b? Here we are saying subtract this from this, subtract this from this. So here 3 will go, and now what else? 2 will go, so 1 is left. So 1 would be set of this difference sets. Now set formulas, we have this set formulas. We have this set formula. Let's say some of the most important set formulas are for any three sets A, B and C. Here we have n. A is a union B is equal to A is equal to n number of set number of, okay, this is very complicated. We will see it later, this formulas. This is commutative property. Okay, we are crystal clear about it. Law of union, complement law. Examples. So when you will click on this, then you will understand about it in too much basic. Unions of sets, intersection sets, complement set formulas, all this we have discussed this. If you click formulas, then you will come over here. This is a table of content. We have discussed it. Now sets, subset and superset. We know what is universal set, disjoint set, finite and infinity set, complement set. Let's explore it. Sets definition. We know this set theory, Venn diagram. Complement of a set. If U is a universal set and A, B any subset of U, then Venn diagram for the complement of a set. In this, what will happen? The given complement of a set example. Thus, we can see that A in this we have this is also in this. This is also in this. this was about this. If we click on this, then what will happen? We now this card. Okay. Okay. If n is a set of natural less than n, so the coordinates, this would be, can we say that t, what is an infinite set? Properties of n in infinity set. We will explore it later. How to know if a set is infinity or infinity. As we know, if a set has a starting and ending point, it is a infinity set, yes, but it is a infinity, but it is an infinity if it has no end from any side or both sides, then this is a, but it is infinity if it has no end from any. Yeah, we know. Graphical representation of infinity and infinity sets. Here in the above picture we have this 1 2 3 4 5, this is infinity. 1 2 3 4 5, this is in this set, and 1 2 6 5 6 7 8 is in this set. Union would be what? 1 2 3 4 5 6 7 8, this would be union, and intersection would be 1 2 1 2 1. Both A and R infinity sets as they have a limited number of elements. So here this has in this number of elements are 5, as well as this are in this number of elements are 5, both are equal. That's why this will be known as equivalent subset. Equivalent subset, like that. Okay, this is done. This was main table content of this lecture. Important question. Types of set. Power set. Operation on two gates. Types of sets in math. Empty set, we know Singleton set. Yes, infinity power set. We are all crystal clear about it. Okay. Power set. Example of a power set. Now, what bonds have we discussed? Let's see from starting. We had started from where we started with the meaning of a set. Then we saw table of content of this lecture. These are topics that we discussed. First of all, set, then all this. In details, we discussed it as much we did. Then after defining the set, we discussed types of a set. In this types of a set, we saw empty set, then singleton set, then infinity and infinity sets, then equal sets, then subsets, then power sets, we discussed it, then inversal set, we discussed it, union of sets, properties of union of a sets, then intersection of a set, it has only common element, difference of a sets, we saw this, and disjoint sets. Then apart from this, we discussed from this table content. From this table content, where are you? Here. Then we go subset. All subsets symbol. Proper subset symbol. This is a proper subset symbol. Okay, proper subset formula. Improper for improper subset it would be like this. This is an improper subset. Just a line below this. Here this is also table of contents about this subset with all subsets, types of a subset. In this you will understand proper subset, improper subset. In details you will understand about this. If you want to go into much more details, then you have this proper subset, then proper subset formula, then subset and proper subsets and proper subset. You can go into much details by clicking on the links that are given by this website. This links will help you more. It is useful for you. If you don't have a more basic understanding, then this link will be useful for you. Whatever you don't understand, then just click on this link, then it will take you to the basic of the current lecture. So this is done. In the next slide we will discuss something else. For now this is done.